Not all hybrid wood stoves are created equal. That statement probably isn't all that surprising given the number of wood stove manufacturers out there and the number of different products and different designs on the market. However, I have two hybrid wood stoves, and just from owning and operating these two stoves, I can tell you that there are some differences in the way that they function based on how they are designed. Now, I've previously made a video on different wood stove combustion technologies. There are non-catalytic wood stoves, catalytic wood stoves, and then your hybrid wood stoves. The hybrid basically combines aspects of the non-catalytic combustion technology with catalytic combustion technology in order to get clean emissions and high efficiencies out of the stove. Non-catalytic combustion requires much higher temperatures in order to burn the smoke cleanly. So non-catalytic stoves tend to have higher draft through the firebox. In other words, they burn wood at a little faster rate to get those temperatures nice and high in the firebox so that the smoke will burn in the firebox. Whereas a catalytic stove uses a catalytic combustor which enhances the reaction or basically allows the reaction to take place that burns the smoke at a cooler temperature of just 500 Fahrenheit is where the catalyst becomes active, and then the smoke burns in the catalytic combustor rather than directly in the firebox. So you can operate at slightly cooler temperatures and still have clean emissions. So that's kind of the key differences there. The hybrid just puts the two together. You get the secondary combustion with the high temperatures in the firebox, and you get the catalytic combustor to clean the emissions. Hybrid wood stoves are operationally the same, and they are operationally the same as a catalytic wood stove. You get the fire going as the internal temperature of the flue gas and the catalytic combustor reaches 500 degrees Fahrenheit. You engage the catalyst, and then you just let the fire go, ideally at a low and controlled burn rate. So that is the operating procedure. Where the differences come in is how the stove is designed to account for both of those technologies. The units I have are the Woodstock Soapstone Ideal Steel, which is a freestanding wood stove sitting behind me. And the other unit is the Regency I-1500, which is a wood burning fireplace insert, part of their Cascade series. It's functionally the same as the Cascade series wood stove, which would be the F-1500, the freestanding stove. And they also have a 2500. So I'll start with the Regency. So Regency made non-catalytic stoves for years. I had one. I had the I-2400. It was actually the first wood stove that I bought for our first house. And it was great. So when we moved to this house, I looked at Regency again and was swayed toward the hybrids. In fact, the whole reason I have both of these hybrids is because of the tax credit that was in effect for 2021, 2022 for biomass. Regency made non-catalytic stoves for years, and they were really solid units. And what they've done with the Cascade series, like the I-1500 and the 2500, is essentially take their old fireboxes, their non-catalytic fireboxes, and then put a catalytic combustor with a mechanism in there, and that catalytic combustor basically goes over the flue exit on the stove. So when you engage that catalyst, it slides kind of across the flue exit, and all the flue gases then have to pass through it. And basically what it's doing is serving as a tertiary scrub on the emissions after secondary combustion has taken place in the firebox. So the Regency I-1500 runs much more like a non-catalytic stove would. The fire in the firebox is very intense. You can't slow it down a whole lot. There's no way to shut off the air enough to eliminate flame in the firebox. You just can't do that. So it runs like a non-catalytic stove. Because the catalyst is right at the flue collar, all of the hot exhaust gas coming out of that catalyst is basically going up the chimney, except for the fact that the blower on that insert brings some air around that. In my opinion, not really leveraging the combination of technologies to the fullest extent that they could. That is rather different than the Woodstock Soapstone Ideal Steel. In contrast, if the Regency is basically a non-catalytic stove with a catalytic combustor thrown in to clean the emissions, this stove, the Woodstock, is the opposite. It's basically a catalytic stove with secondary combustion in the firebox, which gives you flame and a pretty fire to look at in the firebox. And actually having the secondary combustion in the firebox takes some of the load in terms of burning the smoke off of the catalyst itself. This operates very different. You shut the air all the way down, you can have no flame in the firebox, and that catalyst is still giving you clean emissions. In other words, working like a catalytic stove. On the other hand, you can have more flame in the firebox. You can have nice secondary combustion going on, like we do now. So very, very different performance. I would say that the Woodstock Soapstone Ideal Steel better leverages the benefits of both technologies than the Regency does, where the Regency kind of feels like the catalyst is thrown in there to meet those 2020 EPA emission requirements, get the efficiency up a little bit, but the unit itself doesn't burn in a way that seems to be leveraging the full benefit of having that catalyst in there. With a catalytic combustor, you can burn at lower temperatures, you can burn at slower rates, and you can still have clean emissions or clean combustion because that catalyst will take care of things at a cooler temperature than's needed in the firebox. So they're not all created equal. I'm not saying that the Regency is bad. I'm just saying that functionally they're different. I mean, what you do to operate's the same. You engage the catalyst at the same temperature, cat starts working, you know, all of that's the same, but how it actually performs is different. So this is something to be aware of, and unless you're paying attention to how that stove is designed and constructed, you're not necessarily gonna know how it's gonna perform in the real world. So hopefully this little description helps you see that. The other thing is durability. I said that the Regency, it kind of seems like that combustor is an add-on to clean the emissions. Well, when you look at how it's sitting in there, it's in a steel box. There is a flame shield on the bottom of it, but the flames in that stove will wrap up around the baffle going toward the flue exit when you have really intense secondary combustion. And that does concern me a little bit, that the flames are going to impinge on that catalyst. That is practically impossible in this stove because the catalyst is inside of a metal shroud, and actually the flue gases have to come forward, wrap around, back, and then wrap around again forward to come through that catalyst. So you're just not going to get flames reaching that catalyst, and you don't want flames to hit the catalyst. That actually damages the catalyst and will shorten its life. So again, I have some questions about the durability or the long-term durability on that Regency, but it seems to be holding up and functioning fine at this point. Again, just things to think about. If I had a preference, I would want a hybrid that runs like the Woodstock. The Regency does burn nicely. It does slow down the burn rate a little bit when you engage the catalyst because you're restricting the airflow through the stove because it's got to go through the honeycomb of the catalyst rather than an open pipe. But it still burns fast and burns hot and burns hard like a non-catalytic stove with much less control to turn that fire down. Whereas here, I can shut it way down and basically have no flame in the firebox, yet still burn clean. Hopefully you found this helpful if you're looking at hybrid wood stoves or thinking about a hybrid wood stove. I actually really do like them in terms of the way they leverage both combustion technologies. Just be aware that you're going to have to run it like a catalytic stove, and the maintenance is also going to be more like a catalytic stove. Otherwise, the efficiencies are higher and they burn very clean.